Now we're going to talk a little bit about maths, and I don't want you to all run off screaming for the hills. Maths doesn't need to be scary, and this is a very important area for us to cover because it's probably one of the most difficult areas for parents to help their students with in learning at home. Why? I believe that it's difficult because many of us ourselves either A, struggled with maths when we were at school, and so we've got sort of negative experience memories, or B, we can't sort of remember the maths we did. A lot of us, we just did what we had to do to get through the tests and exams. And the third reason is just simply that we're worried about letting our kids down. If we sense they're anxious and tense about maths, then we're concerned that we surely don't know enough to help them, do we? Well, we're going to challenge that a bit today. I don't suggest that you throw out your school programs at all. But as you're working through them with your children, as I said, they will be programs that are written for all grade 5 or all grade 3, but they're not necessarily written to differentiate for your students' learning needs. If you have a student with maths anxiety, chances are they have missing links in the processes that build towards what level they're meant to be on. In other words, if I have a student that is trying to do long division, but they don't understand that division is simply sharing. You've got this much money and you share it out to 4 people. Oh, suddenly division means something. Or for example, if they're doing division, long or short division, then they may not understand how their times tables work. They've just rote learned them. So division is backwards rote learned times tables. And when things are just a backwards memory linguistic game, which is all that is, then it's very easy to get confused. It's very easy to learn a distrust of maths. So today I can't give you a total maths understanding of all the different concepts of maths that you might come across and need to help your student with. The texts can do that. The books can do that. But what I need to give you is an ability to make judgments about when the program is not working. This may be a challenge for some of you as parents because you may have found the very things that your student is struggling with difficult when you were at school. Or as I said before, you have some knowledge of it, but it's a long time since you did it. Try and relax when you're dealing with the maths with a student. The first port of call I would suggest is when you're having trouble to see if you can get some help from your school. If you can't, then refer to the maths notes that we put the link down below and go through them. You will find yourself and your missing links on that page there too if you've had struggles with maths. And if you help yourself with maths, then when you help your student, you'll be a lot more confident, a lot more relaxed, and getting rid of that anxiety out of that situation. Within the maths notes, you'll find information on counting games and how important that is. How important it is that students have a conservation of number. In other words, 2 is not just the number we say before 3 and after 1. It actually has a value of 2 objects. That's called conservation of number. To get meaning in the numbers, of course, modeling with tangible physical objects, even counting jumps on a trampoline or bounces on a trampoline is vitally important for younger learners. As we come through there, we're talking about modeling place value and seeing what 1 looks like compared with 10 and 100. And a good way to do that is using the MAB blocks, the maths attribute blocks, which are available from educational centres, or the school may even loan you some or be able to. Or if not, you can make a picture representation of those blocks by looking up maths attributes on Google and click on images, and there'll be pages of templates, I'm sure, somewhere there. So that you can have a model of these numbers and what they represent in picture form, which is the next best thing to concrete objects. Younger children also need an understanding of addition and subtraction of single digit before they get into multi-digit. You might have been set work from the school or the program that has them doing double digit subtraction, and yet you know your child can't do the basic subtraction or can't sometimes even do the addition. I've got a flash fingers game in the maths notes there, very powerful, and also the rainbow facts. Understanding the rainbow facts, the groups of numbers that go together to make 10. 1 and 9, 2 and 8, 3 and 7, 4 and 6, 5 and 5, and so on. I've got a place value game in the maths notes as well, throwing a dice, and you've got 7 throws and your target is 1,000. And the first throw, it's a 2. You might write down 2, your child might write down 20, another child or student you have there might write down 200. And so the number can represent a different value held out by zeros. And this is a great way for them trying to make a target of 1,000 in just 7 throws. And they're not allowed to go over, but they'll have a choice in those 7 throws of which numbers they make single, double or triple digits. I've got a little bit of information on place value tables, and then something else that is a big key, one of the most powerful tools I've ever seen actually for helping children with their addition and their computational maths. I've also got some information there on a game called The Easy Way. It involves writing strings of numbers. For example, 2 plus 8 plus 6 plus 4 plus 9 plus 1 and so on in a pattern. And you might do similar sums for 2 rows. And what does that equal? And you're teaching the children to spot the patterns. The 2 goes with the 8, the 6 with the 4, the 9 with the 1, and then they just add it together, counting in lots of 10. So again, it's taking things back to that decimal system. And this might be a much longer sum, but they also learn that no matter how many numbers there are, how big the sum is, it's no more difficult than just the segment, okay, when they break it down. I'd do 2 similar to that, and then I'd move into mixing the numbers up. And so then they've got a 6 with a 4 there, they might put a 9 with a 1 there, 8 with a 2, this ended up a bit symmetrical. Okay, and I'd do these up to like 80 or 90 long, and children are quickly learning to computate longer sums. And then you have 2 similar to that, then you would have 2 where you are teaching them to break things down, like 8 plus 8 plus 4 plus 8 plus 6 plus 6. And you might mix in some of these as well. But when you're doing this, you're forcing them to say, hang on, I'll chop that and put 2 on each 8. So there's 10 there, and then I chop this 8 into the 4s that are needed for the 6s. Okay, there's 10 there, 10, 20, 30, 40, and so on. Now this then moves on into double digits. As I said, this Easy Way game is extremely powerful. I've used it over 20, 30 years. I've never found anything as powerful for quantum leaping younger children's maths, relational understandings for addition, which then carries over into subtraction. Okay, now we're going to talk about multiplication. Multiplication is probably the most complexing operation to children at grade 3 level when they first venture into it. Why? Because not enough time is spent on what it means. A lot of children know multiplication is times or times tables, but they won't understand that it's lots of or sets of, okay? And they may know it's skip counting from their 5 times tables or 2 times tables, but underlying all this as a foundation needs to be repeated addition. I explained it to children that you wouldn't want to have to go to a shop and say, can I have 2 plus 2 plus 2 plus 2 plus 2 shoes, please? Instead, you would say, can I have 5 pair of shoes or 5 twos of shoes? 5 lots of 2. So we're talking about this here, this symbol, as lots of. And that's the language I'd use with children. Why? Because every time we say lots of, we're reminding them that we're talking about 3 lots of 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 3 lots of. 4 plus 4 plus 4. And this, of course, is repeated addition. Okay? Which is sets of lots of, which is also skip counting. 4, 8, 12. Which is times 3 times 4 or 4 times 3. But we're trying to keep this into the concrete, things they can see and do. I'll give you another little key for this as well. This is called crossover. Crossover multiplication. And crossover multiplication is quite simply where you go 3 times 1, 2, 3, 4, and they just count the crossovers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now it's so simple how it works. Why? Because you can see there's a lot of 4, another lot of 4, another lot of 4. So it's 3 lots of 4. Or if you did it this way, then it would be 4 lots of 3. So what we have here is a good basis now for understanding what on earth multiplication is, how it works and what it means. We've got picture, simple representation. We've got language that they're familiar with from learning about addition. So then we move on to covering a greater range of times tables or multiplication sums. And in doing this, we've resorted to rote learning times tables because the students haven't really understood what it means. But if you understand what it means, you can learn patterns and systems for all the times tables. And then you will have a greater instant recall of these sums because you'll be able to remember them. Rote learning them over and over and over is not necessarily the answer. In fact, what has a greater effect is if the new piece of learning is connected to other areas in the neural net. There's more branches connecting that piece of information, and it allows you to be able to retrieve that information. So let's look at an example now around the 5 times tables. I use this example to help parents understand why we need to change the approach to learning our times tables from rote learning to relational understandings. And I'll often say to the parent and child sitting in front of me, or children in front of me, I'll say, okay, let's have a go at some multiplication. Let's do 5 times 6. And they can all work that out usually, 5, 10, 15, 20, 25, 30, and they do skip counting. Skip counting is, by the way, one of the weakest strategies, but it's still a strategy. And then I might put down 5 times 8, and they'll work that out, that's 40, and then they might do 5 times 12, which is 60, and then I might do something like 5 times 248. And they go, oh, I can't do that one. And I say, well, you will be able to do that one very soon because it's no harder than these ones if you know how the numbers work. I say, and if I've heard them going 5, 10, 15, 20, 25, 30 up here, I'll often say, could we try your strategy? Let's try the strategy, 5, 10, 15, 20, 20. And then I laugh and I say, we're going to be here for a long time, aren't we? Counting up to 245 times, skip counting in 5s. So instead I say to them, you are going to help me find the pattern for this. And I'll say, what's the relationship between these two numbers? What do you do to 6 to make it into 3? And they all work that out. Sometimes I might model for my fingers with them if they're really struggling. I go 6 into 3, and they'll go, you're halving it. That's correct, we're dividing it by 2, we're cutting it in half. So we divide it by 2, oh look, it's got a 0 on it. I don't know what that's about. Okay, and then I'll say, well, let's look at this next one here. Is it the same? And they go, yeah. Half of 8 is 4, divided by 2. Cool, oh look, there's that 0 again. And then I'll say to them, so what are we doing when we put a 0 on something? And usually they can tell you, we're timesing it by 10. But if they can't, it's not helpful for me to just tell them the answer there. I have to model it and have to go 2 times something, or 2 lots of something equals 20. What do I have to do to the 2 to make it into 20? And then I might do another example as well. And the 4 with a 0 on it, when I'm putting a 0 on it, of course I'm multiplying it by 10. That way they can see and understand. So I haven't just told them the answer. So when we do this, we're timesing it by 10. That's what it means when we put a 0 on something. That in itself is a very important concept that a lot of students are missing. So I say, well, let's have a look at this one then. What we're saying is we're multiplying it by 10 and then we're halving it. So let's try reversing that order. Okay? So they can multiply it by 10, get 120, halve it, get 60, or they could have divided it by 2 and get 6 and multiply it by 10, which is 60. Now I say to them, so are you telling me to work this one out here? All I really need to do is halve this number, 124. Notice I'm working that way, not the way they teach us at school, with sums that way. And just put a 0 on it, which means I've halved it, and then I've times it by 10 to get the 0 on. And they say, yeah, well, that's what we did up there. And I say, well, let me show you now a little picture with my fingers to help you understand that. What we're really saying is 5 lots of something. No way. Let's do 10 lots of something. So we multiply it by 10, and when we multiply something by 10, all we have to do is add a 0. So it's much easier than multiplying by 5. Okay, so multiply by 10 instead, which is add a 0, and then because we didn't want 10 lots, we take half away. And so that's a real clear picture pattern for this formula, or this way we're dealing with it. So what we've done here is 5 lots of 248. We've times it by 10, 248 times it by 10, put the 0 on, and then we've halved it. Half 2,000, 1,000, half 400 is 200, half of 80 is 40. And that's the correct answer. Now, when I show children this, and the parents, usually both go, whoa, wish someone had showed me that before. That would have saved me a lot of time. It's very rare that I have students say, no, that's not how you do it. They can see it's the right answer, it makes sense to them. I'll usually then follow up with a few fun examples. I'll say, okay, try an easy one, 5 times 24, and try doing that in your head. And we'll verbalize the process. So we'll do it together. Let's talk about it. We're not going to write it down. So 5 lots of 24, no, we're going to times by 10 instead. So let's put a 0 on the 24. What's that make? And they'll say 240. And I say, now what's half of 240? And they'll halve the 200 and half 40 and get 120. And they'll be quite excited about that they can do that. This is real confidence building stuff. And then you, after a few examples of that, you might throw in something like this. So, 5 times 248,642. And by this stage, they'll just simply go like this. The student will know straight away. And they'll just do it, just straight off like that. Now this is an important thing that is missing from a lot of primary maths. And that is teaching the children that as the numbers get bigger, they don't get harder, they don't get scarier or spookier. So you can see that this is real confidence building stuff. I get a kick out of helping families with this, and I've used the same model for probably 20 or 30 years, helping students in my teachers' classes or my own classes to overcome their maths anxiety, to realize they can do it. The bigger numbers aren't scarier, but it's about meaning. From this, I would say to the student, so are you telling me that 5 anythings, I'm too lazy to write every number in the world, I'm just going to use the word anything, but I'm too lazy to write that, so I'm just going to write A. So 5 A's equals 10 A's, or 10 anythings, cut in half. That line means divided by 2, which is the same as that. Okay, so 5 anythings equals 10 anythings cut in half. Once again, if we model that with our hands, it's just so simple. 5 anythings equals 10 anythings cut in half. Wow, it's so simple when you do it like that. Guess what we call this? We call it algebra. Okay, so using a variable. A is not apples and B is not bananas, as I was told when I was at school. These things actually mean something. When things mean something, we're able to connect it to other points in our neural net so we can retrieve that information. It's sad to me to hear of the millions of students the world wide over that are rote learning times tables year after year after year after year, when they could just learn the patterns and systems for them. So having a formula or understanding that puts the numbers together is very important. If we take our 9 times tables, 9 lots of 6 equals 54. A lot of students have rote learned that, or they might even use the magic fingers calculator. 6 lots of 9, so they put down the 6th finger equals 54. Now that's very clever, it works for all of the numbers up to 10. So if we go 8 times 9, we put down the 8th finger, equals 70, 7 on this side, 72. But what happens when we say 9 times 18? Whoop, now we're up the creek. Now it won't work, will it? So 9 times 18, using this, it's limited. The fingers trick is a magic calculator. Skip counting in 9's very difficult to do. The skip counting is not going to work. Okay, there are other strategies, but quite simply, if we take everything back to the decimal system, back to the 10, or lots of 10, let's do that with 9. So 9 lots of anything, so 9 anythings equals 10 anythings, take away 1 anything. So that's the parallel formula to what we did for the 5s there, the algebra behind 9 times tables. So this doesn't just work like the fingers calculator up to 10, it works for any number, and that's when this becomes powerful. If we have 9 times 18 now, using this it's no worries. All I do is go 18, put a 0 on it, as it's times by 10, and then I've just got to take away 1 lot of 18. And the trick there is as well, is you don't take away 18, you take away 20, which equals 160, and then you add on 2, okay? Because it's easier to take away 20 because of place value and add on 2 than it is to take away 18. So the power of the numbers for learning your times tables. So in the maths notes, you will see the patterns and systems for all of the times tables. If you've got students struggling in maths going on from grade 3, 9 times out of 10, they have a problem with not understanding how the times tables work. I'll give you another example for a close. If we look at memorizing our times tables as simply zip, zog, woo, boo, 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 do, 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 and some memory linguistic game, there is no maths meaning attached to it. And without the meaning, there is no purpose to maths. So what happens if multiplication is just backwards rote learned times tables? What happens when we go to do division? Well then, division is backwards rote learned times tables. And that is absolutely crazy. Backwards rote learned times tables? That's not maths, that's just confusing kids and causing anxiety. So I hope this gives you a snapshot into multiplication. We talked about the basis for multiplication, what it means, sets of lots of crossover multiplication, seeing those relationships in the numbers. And now we've taken a common example of times table like 5 times and 9 times, but worked it through so that there is full understanding of what it means. In the maths notes, you'll find the pattern systems for all the times tables, and I've even got some advanced multiplication strategies in there as well. So I hope the maths that we've been through and the maths that you can get into within the maths notes helps take away that anxiety around maths, helps create situations where you and your student can learn together. Remember, if you're not getting something, it's not their fault and it's not your fault. You're just on a journey together. Make it a little challenge. So as I said before, maths can be fun and engaging. It shouldn't be something we're scared of. As I said, don't run from the hills when your child asks for help with the maths. And don't get nervous. That nervous and anxiety will project onto the child and make them feel like they're doing something wrong or not good enough, similar to as we talked about in earlier videos. Today, I'm covering some of the basic areas where students get left behind in that journey of maths. We're not saying to pro out the program, but we are saying you're going to need to make informed decisions about when pushing on that wall is not working. You need to stop, relax, have a look at what's missing in the understanding. Get help from the school if you can, help from the maths notes or this video today. Thank you for listening. All the best with your journey.